Good evening, ma'am.
Okay. So today we will cover, revise graph theory, mainly week 10 and week 11. Okay. And after that, I will cover the questions from mock test. Okay.
Ma'am, at the end of the session, can you share some questions for practice from graph theory?
Yeah, sure. I have a couple of questions. Submission.
Like, apart from what we discussed in the session, apart from that for practice.
Okay, so apart from them, okay, I'll try to provide some exercise question from some books.
Thank you, ma'am.
Ma'am,
Yes.
ma'am, what's the weightage for mathematics, ma'am?
Sorry, what?
Ma'am, weightage for the exam.
Weightage. Yeah. So you can consider one or two questions from week 1 to 4, one or two questions from week 5 to 8, and major portion will be from week 9 to 12. So you can assume some kind like 75% from week 9 to 11 and remaining 25 from 1 to 8. So this will be the rough estimate you can assume for interns.
Ma'am, on average, how many questions would we have in total?
On an average, including subpart, maybe 15 or 14 question will be there.
Oh, thank you.
Ma'am, also, will you take some conceptual questions from graph theory?
Yeah, I'll take whatever doubts you have in graph theory.
Okay, thank you, ma'am. Thank you so much.
So
Ma'am,
let's
the level-
first. Sorry.
Ma'am, the level will be like the graded assignments, or it will be more than marks, ma'am?
Level major part of the paper will be as like practice assignment and graded assignment only, including activity question level you can assume activity and practice. In graded, there are some questions which are little bit advanced. So 80% of the paper will be easy.
Okay, ma'am.
My screen is visible.
Yes,
ma'am.
ma'am.
Yes, ma'am.
So let's start. We have to cover a lot. So I'll start by relation. So you guys know that a relation is nothing but any subset of a Cartesian product A cross B. If A and B are sets, then any subset of a Cartesian product is a relation. Yeah, you will find a recording of this session on YouTube. I think they provide some link that you can. Okay, so any relation can be modelize or it can be generate a graph. So what is a graph? First thing. So a graph is any graph will contain two sets. First is the set of vertices, and the second is set of edges. Set of vertices will denote by V, and set of edges is denoted by. So what are the vertices? So vertices are nothing but like points. So you can name any vertex using 1, 2, 3, 4, A, B, C, D, and whatever thing you want to denote, that will be your vertices. So precisely what we do, so we say that if I want to model a relation which is a subset of A cross B, then my set of vertices is nothing but all points from A cross B. So you'll consider all tuples A comma B from not tuples, you can say all points from the set A and B, and you will draw an edge between those 2 points. So what are the edge? If I want to generate a graph using a relation, then an edge will be that there is an edge from a vertex A to a vertex B if A and B are related. That means this tuple A comma B belongs to your relation. So if a relation is given to us, then we can easily modelize or we can easily generate a graph, which will actually give us all the characteristic of that particular relation. Okay. So in a graph, we have some terminologies named to be the what is known to be the path of a path in a graph. Okay. So path is nothing but a sequence of vertices. And in a path, we generally don't repeat a vertex. So if we are repeating a vertex in a path, then that is known to be a walk in that particular graph. So for sake of generality, let's say this is my graph, and I name the vertices to be 1, 2, 3, 4, 5. Then here, if I say that a sequence of vertices, namely 1, 2, 5, then this is a path from a vertex 1 to vertex 2. Now, what is a cycle in a graph? So a cycle is nothing but a closed path. That means once you start with the vertex, you have to go around all the vertices in such a way that you will end up with this same particular. For example, in this particular graph, if I consider the sequence to be 2, 5, 4, 3, then this is nothing but a cycle. Yeah, I'll discuss mock questions at the end of the class. So that's all about walk path. And then we have directed and undirected graph. I think you guys are already familiar with. So we have one reachability question, right?
What is the difference between a path and a walk?
Actually, in a walk, we can repeat a vertex. For example, in this graph, if I define a path name to be 1, 2, 5, 3, 2, and okay, so here we have less number of edges. So let's say I add one edge, and if I define a path name to be 1, 5, 3, 2, 5, 4, 3, right? So here I am actually repeating so many vertices. I'm repeating 5. I'm also repeating 3 also.
3 and
repeating
4.
4 also. So
Okay.
this is going to be a walk.
It need not be a cycle, right? A path.
Yeah, it need not to be a cycle.
Okay.
So a path is a cycle only if the starting and the end points.
Okay, got it now. Thank you.
So
Ma'am,
we
what's
have a
the meaning of-
reachability.
What's the
Sorry,
meaning of
what?
E in V, comma E?
Sorry.
What's the meaning of E in V, comma E?
Edge.
Okay, okay.
Acha, oh, okay, fine.
Yes, ma'am, you can tell.
So we have one reachability question. So that means this question actually generally answer that if I have a graph, then can I find a path between any two vertices? So this question can be handled using the reachability thing. So we generally saw trees, spanning trees, and all those things. All those things can answer this reachability question. Okay. So let's move ahead. Now I'll go towards the main topics known to be the covering. Before covering, let's say we define what is the coloring of a book. Okay. So coloring of any graph. So what do you understand by coloring? Is simply we have to assign some colors to the vertices in such a way that no two adjacency vertices will take the same thing. So that means coloring is nothing but a function. So we can define it via a function that C from this set of vertices to some set which contains colors. So let's say red, blue, black are the colors here. So coloring is nothing but a function from the set of vertices to some set of colors in such a way that if two vertices A and B are related, that means if two vertices have an edge between them, then they should attain different color. Then C of A is not equals to C of A. So a function which is respecting this condition is known to be a color. So in general, we say that if I want to color a graph, so that means I want to find the number of colors which are required to color my graph using this particular restriction. So that means what is the restriction? If there is an edge between two vertices A and B, then you will give different color to these two vertices. You can take one to be red and one to be blue or whatever color you right. So this is a particular aim of coloring a graph. So if someone asks that find the minimum number of color to color this graph. So you always keep in mind this restriction. Okay, because if we don't consider any restriction, then a single color will be enough to color all the graph, right? We don't need more than one color. So using these this particular restriction, you have to answer how many, what is the minimum number of color you required for coloring graph. Okay, so I'll ask you a very simple question here. So answer me. So find the minimum number of colors to color the following graph. So I'll give you two graphs, number A, number B. So here, since we haven't discussed any particular method for coloring, so you just have to use your intuition. So that means first fix a color to a vertex, and then say that particular color can be used to how many vertices, right? So you just have to use your intuition. This is my one graph. So these are the set of vertices, and there are edges. And the second graph is this is the second graph. So you have to answer what is the minimum number of color we require to color this particular. Okay, I'll give you 2 minutes.
So
Just think and answer in the chat box.
Sir, the answer is 2.
Yeah, you have to.
Both the cases, the answer is 2.
Yes, ma'am. 2-1.
Ma'am, for A it is 2, for B it is 3, ma'am.
For
The
B3,
first one
what
it is
the-
2
what the-
and for second one
Yeah,
it is 3.
it's 3. Yeah.
So next time, keep in mind the answer in the chat box, so that if you missed, we have to give some time to others also, right? Okay, fine. So the answer is, we will find out. So one key observation is here are even number of nodes. So that means 1, 2, 3, 4, 5, 6, 7, 8. And here the odd number of vertices are. So that means 1, 2, 3, 4, 5, 6, 7, 8. So what happened when we have different number of vertices? That means this is a kind of cycle, right? So in a cycle, we have one side we have odd number of vertices, and another side we have even number of vertices. Okay, so let's start coloring this graph. So if I can give vertex number 1 the color yellow, I can give yellow color here, yellow color here, yellow color, right? Because they are not adjacent. And second choice I can give blue color to these vertices, right? So that means this graph can be colored using
Yellow,
blue
red,
colors.
yellow, red. Yellow, red is
So
yellow.
here, if see here, I can color these 3 vertices using yellow color, but I cannot color any other vertex using the same yellow. So I'll just take blue one to color these 3 vertices. Again, for this vertex number 6, I don't have any choice to take another color. That means I have to use 3 colors. So that's why here the minimum number of colors will be 3. Okay. So is this any doubt in this particular problem?
So for any graph, the minimum number of colors would be either 2 or 3, depending on the even
for
or
these type of cycles,
Mhm.
if you consider the cycles, then yeah. For another graph, you just have to use the same method. First, pick a color all the possible vertices which are not non-adjacent using that color, and then if you need, use another. Okay, so that's the successive method you can. Okay, so let's move on. Those second thing is the set of. Okay, so one thing is we say that 2 vertices V and U and V are adjacent to each other if there is an edge. Just say if there is an edge between them, right? So these are known to be the adjacent vertices. Now, using the adjacent vertices, we will define what is our adjacency matrix. So adjacency matrix is nothing but a matrix related to a graph in such a way. So suppose I have a graph G with the set of vertices to be V and E to be set of edges, and the cardinality of V. So that means the cardinality of V is equals to N, means that I'm considering a graph with N number of vertices. Okay. So any graph with N number of vertices can be easily denoted by a matrix of the size N by M in such a way. So we form this matrix in such a way that I'll say the ijth entry of the matrix is 1 if there is an edge between I and J. And the ijth entry of a matrix of this particular matrix is 0 if there is no edge between I and J. There is no edge between I and J. So using these two description, I'll define a matrix related to any graph. Okay. So I have a simple question here. So if you have an undirected graph, then the adjacency matrix will be
Symmetric.
right, symmetric. Why is this so? Because in an undirected graph, if there is an edge between the vertex I and J, then we can easily say that this is also an edge between the vertex J and I. Okay. So this is a one point.
Ma'am,
Yes.
sorry for interrupting you, but I just wanted to ask that when will we have the mock discussion session for math?
At the end of session. First, I'll discuss week 10, 11, and then 1.
Okay, today we will have.
Today I'll discuss all the graph theory questions in the mock. You already had your calculus revision session. Are you guys revised calculus?
Yes, ma'am.
Yes.
Yes, ma'am.
Ma'am, but its
So there
session
have you
is
discussed.
end before the
Yes,
10,
ma'am.
before 10 p.m. When I entered the session like 5 minutes or 10 minutes ago, the session is already ended. So I have a doubt in the unique tangent.
But why do you enter before 10 minutes of
Because
10 p.m.?
I don't want to disturb anyone in the revision. If I ask the question into the session, then everyone will get disturbed.
Okay, so we can.
Common doubt, ma'am. Why they cancelled the mock test discussion, ma'am, for maths?
Actually, we plan to discuss mock in 2 parts. First thing is calculus questions, and the second thing is graph theory question. So the calculus question I have to address. The calculus question will be addressed on calculus revision session and the graph theory part here. But actually, other instructor were not given any instructions over the mock test. So I think I have to discuss all that. Okay, so I will discuss. Yeah, we'll take
Calculus completed, ma'am.
Yeah, calculus revision session is done.
I'm asking mock test discussion for calculus.
You guys tell, is it done or
it's
not?
not been done.
No, ma'am.
So okay, fine. So we'll go
Yes,
to
ma'am. There is no
Ma'am,
session for
we
mock
have so
mock
doubt,
test solving
we have
session
lots of doubt
for
in mock,
math.
ma'am. So please clear it.
Okay. So yeah,
today itself.
I'll discuss it same today. Okay, so what I can do, I'll just quickly go to the main concepts of graph theory. I won't go that much deep as I'm going now.
Yeah,
And
yes,
after
ma'am.
that,
I have a
we
doubt
will
in
see
graded
Yes,
assignment
ma'am.
11 to 3 question of graphs.
Okay, fine.
What if you
So
take
just,
a different class for mocks? I mean tomorrow
Sorry?
maybe?
No, actually, what's happening now, your end term is near, right? So we have revision session for all courses. So it will be tough to schedule any session tomorrow.
Tomorrow, can you please
There is
have
there is
a class
clear
for mock test discussion,
math.
ma'am?
Wait. Yeah, I know there will be one. There is one class for mock discussion, but I think that class were cancelled or something.
Yeah,
is
it's
happening. So, okay. So what we can do? It's 8:25. So for 9 p.m., I'll discuss all the main concepts of graph theory. Then we will take all the doubts and questions from graph theory, and after that we will switch to mock. That
Yes,
will
ma'am.
be fine.
This
So
will
it
be
will
better.
go beyond 10 now, ma'am.
Yeah. I will try to wind it up now. Okay, so now I'll mute everyone. So I'll just go through the theory thoroughly. I mean, for from starting to end. And after that, I'll ask all the theoretical doubts. Okay. Is that fine for you?
Yes, ma'am.
Yes,
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 ma'am.
ma'am. It will be
perfectly
better,
fine,
ma'am.
Yes,
So
ma'am.
if you have doubt in any topic, just mark it down and you can tell me at the end.
Okay, ma'am. Okay.
Okay.
So let's start. So but for this thing, I need your answers. So this is a particular adjacency matrix. Now I have one question here. So I will give you one adjacency matrix named to be this one. And here you have to answer the question. I mean, you have to draw the graph using this particular adjacency. Okay, so 0, 1, 0, 1, 0. Is there any doubt in adjacency matrix, or I can skip this concept? I mean, it's very easy. You just
Ma'am, you
have to
can
put a
skip this
line
one.
You
here.
can skip this
Skip,
one.
ma'am.
Yes, ma'am.
Skip.
So let's go towards independent set and vertex covering. So what is an independent set? So independent set is nothing, but you have to collect all those vertices which are non-adjacent. So non-adjacent, right? So if two vertices are non-adjacent, you can put them into your independent set. Now independent set can differ person by person. For example, I will say if this is my graph, 1, 2, 3, 4. Then if I consider the set of vertices, namely 1 and 3, then this is an example of independent set. And if I consider the set to be 2 and 4, then this is also an example of independent set. So independent set is nothing, but you can say a subset of vertex. And then if they are non-adjacent, then these two vertices are independent. Now second is vertex cover. So what is vertex cover? So vertex cover is nothing, but again a subset of okay. So what is a vertex cover? So vertex cover is nothing, but again a subset of set of all vertices in such a way that if you collect those vertices which can cover all the edges, V1, V2, V3, and so on, Vn. So this set is known to be a vertex cover. If there is an edge in your edge set, then there should be two vertices from this vertex set, Vi and Vj, which denote this edge. So that means the edge between Vi and Vj is nothing but that particular edge. So for example, if I have this graph, then ultimately what you have to do, you have to collect all those vertices. Suppose 1, 2, 3, 4 is my vertices. So then you have to collect all those vertices which can cover all the edges. So suppose I will take 2 in my vertex cover. So if I take 2, then this edge, and this edge is associated to 2. So that means it will cover these 3 edges. Now, since I have to cover all the edges, I have to consider the vertex number either 4, 3, or 1. So if I consider the vertex number 4 also, then I can cover this edge, and this edge. But still this middle one is new. So that means I have to consider one more vertex. So this is an example of vertex cover. So vertex cover is nothing. You have to collect all those vertices which can cover your whole graph. By covering your whole graph means if there is an edge between any two vertices, then these two vertices should be a part of, one of them should be a part of your vertex. So suppose there is an edge between a vertex A and B, then either A or B should be a part of your vertex. Okay. Now third point is matching.
Ma'am, please
So what
repeat
is matching?
independent set.
Yeah, explain independent set. So independent set is nothing.
An example of independent set.
Sorry, what?
Can you take a question of independent set?
See, independent set is nothing. You have to collect all those vertices which are non-edges. Right? If there is no edge between a vertex 1 and 2, then you can say that these two vertices are independent vertices. And then you have to collect all the independent vertex. That will be your independent set. For example, here. Okay, so let's consider one more example. So suppose I'll consider this example. Okay, so here are the vertices 1, 2, 3, 4, and 5. So I'll ask you, so if I define the subset of vertices I to be 1, 3, and 5, so is this an independent set or not?
No. No.
Okay, because the vertices
Are
1 and
connected by
5 are
edges.
connected by edges. So that means independent set should contain all those vertices which are non-edges. So for example, if I consider 1, 3, and that's it. That's are the maximum number you can consider. So now this is an independent set. Okay.
Ma'am, excuse me.
Ma'am,
Ma'am,
can you explain
once
vertex
again?
cover?
Independent set, ma'am. Independent set, can you explain it again, ma'am?
Ma'am, I have one doubt. This independent set is anywhere related
Yeah,
with
just
color theorem?
see, independent set is nothing. If there is an edge, then these two vertices are not independent. Again, you have to just consider all those vertices which are non-adjacent. That's okay. So directed graph is in directed graph. If you want to find independent set, then just respect the direction. For example, if I make this to be a directed graph. Okay, so here what happened? There is an edge between 5 to 3, but there is not an edge between 3 to 5. So I think in directed graph, we saw independent set only in undirected, not in directed.
Yes, ma'am. Yes, ma'am, because
So
we
there is
cannot
no
say that.
terminology of, yeah, right. There is no terminology between independence and terminology.
Ma'am, can you take a question for vertex cover?
Yes, ma'am.
I
Vertex
just
cover.
have explained this vertex cover. I mean, see, vertex cover is nothing. You have to collect all those vertices which can cover all your edges. For example,
You can take the maximum degree of vertex. The vertex has the maximum degree.
yeah, that's the one approach to find out the vertex cover in any graph. If you want to find out, just first consider the vertex with maximum degree, then after that the smaller degree and so on. So suppose this is a one kind of graph. One, two,
In the
three,
direct
four.
it will be in degree, maximum in degree.
Indirected, maximum in degree you can consider. But I think these two concepts we just describe for undirected.
Okay.
Okay. So now what will be the vertex cover in this case? So if I consider, since the degree of 1 is 3, degree of 2 is also 3, degree of 3 is also 3, this is also 3, this is also 3, this is also. So here, if I consider the vertex number 1, right, then these 3 edges will be fine. Then I have to consider any vertex, so let's consider vertex number 5. Then these 3 edges will be fine. And at the end, consider the vertex number 4 and 3 also. As I consider 4, these 3 edges will be fine. Consider 3, these 3 edges will be fine.
Any one of the 4 or 3, right?
Any one of the 4 from these 6 vertex you can consider. So again, the vertex cover is not unique. So you can find out many vertex cover, but the minimum number of vertex cover is unique. So that means the minimum number of vertices is unique. So that means if someone asks that find out the minimum number of vertices which can cover the graph, so that number is unique. So if a question can come up, related to the vertex cover, they will just ask you what are the minimum number of vertices for covering this whole graph. Okay.
Ma'am, in this case, it would be 2, right?
No, I think we need 4 vertices. Because if
No,
you
only
consider
like if we take 1 or 4, so 1 is covering 6, 4 and 2, and 4 is covering 5 and 3 also.
No. We don't have to cover vertices, we have to cover edges. Vertices, we have to cover all the edges, not all the vertices. That's the thing in vertex covering. For example, if I consider vertex number 1, that means this edge and this edge can be defined. So if I consider 4, then this edge can be defined.
I
But
think,
again,
I think, ma'am, the
particular edge-
minimum vertex covered in that case is 3.
So here it will be 3 or
Yeah, ma'am.
no,
1, 3,
Ma'am, it
5.
should be 3 only.
Yes, 3 elements.
And 1, 4, 3, 1, 3, 5 can.
Yes, only 3, ma'am.
okay, we can consider this one.
Ma'am,
Fine. In this case,
And
it's
the maximum independent set is 3, also 3.
you can find
Complement of this.
Ma'am, this matching part I couldn't understand.
matching part. Yeah, I haven't defined matching. So what is a matching? So matching is nothing but you have to consider a subset of edge set, right? So you have to consider all the subset of edge set, any subset of edge set in such a way that any two element in this particular set, for example, if I consider E1 and E2 are two edges which belong to my matching, then they both should have different endpoints. That means in a matching you can consider all the edges which are having different endpoints. For example, if I take the simple graph, this graph 1, 2, 3, 4. So here we have 4 edges, E1, E2, E3, E4. So here one matching you can consider to be the set of E3 and E1, right? Because these two edges are not, they are not sharing any common vertex. So that will be your matching. So matching is nothing but a collection of all edges which won't share any common vertex, right? Or they don't have any common endpoints. So that collection is just known to be matching.
Yeah, okay.
So in that case, ma'am, we can't take the adjacent edges like E3 adjacent.
Right, correct.
In that case, we can
If
skip
these
that.
two edges are, if two
Is
edges
it
are
similar
adjacent, you
to
can
the
take only
independent
one.
set?
We can say in some sense, because again, in independent set also we are somehow, but there we are considering the vertices. Here we are considering the edges. So that's a little difference. Although the concept is same. If two edges are adjacent, you
We
don't have to
actually
consider.
talk about the edges, right? When the vertices.
Independent set related to set of vertices, and matching is related to set of edges.
Okay. Can we relate independency with the color theorem like that? They both will be same or different?
No, actually we can't. There is a one famous theorem, but that thing you can learn in your future graph theory books. It will be a little bit advanced.
No, one of the
But there is a connection between matching and independent set. Sorry, what?
One of the class, sir, use this color theorem to find the number of maximum independent
Yeah,
set.
in the team session.
Yeah, you can find out using that.
I was saying that
Same number of matching
independent set is equal. Yes, ma'am.
Yeah, there is one connection. Yeah, so something like no, but if one is maximum, then another one should be minimum. So maximum.
Ma'am, you can go ahead.
Yeah, we don't have to. I'll suggest one book. Your voice is breaking. Okay, so we have done adjacency matrix. Yes. Yes, you can go on. Hello.
Hello.
You are not audible, sir. You are not audible. You can type it in chat box. Okay, so basic concepts are done. Matching, vertex set, independent cover. These sets only have 1 or 2 line of definition. If you won't understand, just go and read the definition. That will give you more clarity. Okay. So let's go ahead. Now I'll come to the BFS and DFS process. So I'll shortly
Ma'am, can you explain
explain
the perfect matching?
Okay, so perfect matching is nothing but a matching which can cover whole graph. So, for example,
it need to be independent and also a matching also, I think. Am I right, ma'am?
No, it should be a matching which cover all the vertices.
Okay.
So that means any
like,
vertex
ma'am,
from a
in
graph
the
should
odd
be.
number of vertices, there can be a perfect matching in that case.
Sorry, what?
In the odd number of vertices, suppose we have the 7 number vertices, in that case, we can't have that perfect matching.
Perfect matching. So actually it depends on a graph. If it's your K7 graph, then obviously you can't. These top thing, you can learn in from book. Right. We haven't covered these topics in very detail. We are just covering the basic.
Yeah, ma'am, there is one question in the graded assignment. So I asked you.
Okay. So, if the graph is K7 means complete graph. So that means all the 7 vertices are adjacent to themselves, something like that.
In that case, we can't use perfect.
We can't have perfect. Okay. So now let's quickly overview what is the DFS and BFS process. So I'll take a graph. It's a very famous graph. That's the graph. Sorry, just a second. So it's actually a Peterson's graph. It's a very well-known graph in graph theory. Some kind of look like a star.
Star above pentagon, ma'am.
Yeah.
There is a triangle under the triangle, I think. In
Ma'am,
that case,
star
all
is
vertices
star
are
is
connected
under
to the other.
no,
Star is
under
in
the under the
inside and
pentagon. Yeah.
outside is deep.
Yeah.
So we'll just apply DFS and BFS over this graph and see how different graph we can get. I mean, it actually tells us what is the difference, what is the particular difference between DFS and BFS process. So I drawn is very badly, but yeah, consider this is a Peterson's graph. Okay, so I'll name all the vertices. So I name this 1, 2, 3, 4, 5, and 6 vertices, 7, 8, 9, 10, 11. Did I miss something? There should be 10 vertices over there. Yeah. So I missed. This is the stuff. So there should be 10 vertices. 1, 2, 3, 4, 5, and then 6, 7, 8. So I'll just suggest you take 2 minutes and try to derive the BFS tree and DFS tree in your copy. Okay. What will be the DFS tree for this graph and BFS tree for this graph? Starting vertex, you can take anything. So let's take for generality 1. 1 will be used.
Ma'am, like these type of complex graph will be asked in the exam, ma'am?
This is complex in sense of what? I mean, it's look like complex, but initially see all vertices are having degree 3 and all vertices are sitting nicely. So it's not that complex.
Okay.
In terms of independent set vertex cover matchings, yeah, it's a complex graph. Answering those questions, but in terms of covering BFS tree, DFS tree, it's not that complex. Once you have done, just raise a thumb or say in chat box.
Yes, ma'am. These things are clear. BFS, DFS.
Yeah, that's why I won't spend too much time on this. We just do this one particular.
Yeah, ma'am.
And I think last time I only took the graph theory session for week 11 also.
Yes.
I'm not getting DFS, BFS. Okay, so I'll explain briefly DFS, BFS using this particular example.
I'm getting it, ma'am.
Aditya is there, no? Aditya answer. It's okay if you, but if you are not getting, then I think in previous lecture when we revised week 11, there I spent too much time over this BFS and DFS, as I remember. So you can go and check that particular video. So see, so what does BFS and DFS actually do? It actually gives us a tree. So what is a tree? So tree is nothing but a connected acyclic graph. So that means a graph which is connected. Connected means there should be a path between any two vertices. And acyclic, that means it should not contain any type of cycle. So it's known to be a connected graph. Now, what does BFS and DFS do? So BFS and DFS will extract some kind of a tree from our original graph, which actually answers the reachability question. So that means using the BFS and DFS tree, you can easily answer that two vertices are connected up. So here it's
And ma'am,
already a
DFS
connected graph.
also find that cycle interconnected.
Right. So using forward edges and backward edges and DFS numbering, you can find out what are the possible cycles in here.
Ma'am, by using the BFS, we also can find the shortest distance.
A DFS won't find the shortest distance. You can easily
Yeah, only the
check.
BFS.
Only the BFS will give us the spanning tree. So that means for handling spanning tree problem also, we can use BFS, but since we have Prim's and Bushell's algorithm, we never bother about it.
Yeah, three algorithm we have
BFS.
already.
So let's move ahead and find out what is the BFS tree of this particular. So in a BFS, already a vertex is given to us. So we start with the vertex number 1. So if I start with vertex number 1, BFS says that in the second step, you have to list out all the neighbors of this particular vertex 1. So here, so there are 3 edges associated to vertex number 1, and the 3 neighbors are 6 and 4 and 3. Right. In the second step, BFS says explore each vertex one by one. So that means first explore vertex number 6 and find out what are the neighbors of vertex number 6. This is 6, 4, and 3. So the neighbors of vertex number 6 are again 3. One of them is 1. So here we reduce the parentheses. So the neighbors of vertex number 6 is nothing but 10 and 7. So this is 10. Now BFS process says explore all the vertex one by one. So that means once we are done with 6, we jump to 4, not 10. Okay. So if you explore the vertex number 4, so 4 again having 3 neighbors, 1, 2, and 3. So list all the unlisted neighbors. So that means 3 and 2. Now again 3 is already
Ma'am, 9
listed.
also.
So
Ma'am, 9 also is there.
okay, yeah, 9 is there. Na? So it's 9 and what is this? 2. Okay.
2.
Now 3 will have the vertex, unlisted vertex to be 5. 8 and anything else. 4 is already done. 1 is already done. 5 is there. 8 is there. So 2 vertices only. So they are 5
and 8.
So I think we are done with all vertices, right? Anything else is left? 7 is left. Okay, again we have to go with the vertex number 10. So since we haven't listed all vertices. So if you go with vertex number 10, then 6 is listed, 5 is listed.
Ma'am, in this by forming the explore
we are
all
done
the
with
vertex, I think you don't use any order.
Order means?
Order means like 3 is less
Ascending or
than 4.
descending.
Smaller vertex is 3. In that case, we need to explore 3.
Yeah. It's actually upon you. If you want to go via that order, that's also fine. I mean, in these 3 vertex, you can explore anyone at any time. I can start with 4,
Yeah.
go to 3, and then go to 6. But you can't jump up the level. I mean, once
Yeah.
you explore 3, you have to explore all the unvisited vertex first. That's the process of DFS.
Yes,
right?
ma'am. Yes. Yeah.
But in DFS, what we do, yeah, same vertex should not repeat. If we explored any vertex, then that vertex should not repeat it. For example, 1 is a neighbor of 6, 4, 3. So 1 is already listed, so it won't list. Okay. So now what will be the DFS? But DFS says you don't have to bother about the sequence. That means you can go ahead with one vertex, select one neighbor, and then again go ahead with that particular neighbor's name. So that means here you don't have to come back to the same level until and unless you will finish your graph or you don't have any new vertex to visit. For example, here, if I start with 1, then from 1 I can go to 3, from 3 I can go to 4, from 4 I can go to 2, from 2 I can go to 5, from 5 I can go to 10, from 10 I can go to 6, from 6 I can go to 7, from 7 I can go to 8, from 8 I can go to. So this is a one BFS tree of this graph. So because BFS says that you don't have to consider new vertex every time until and unless you will finish all the, I mean, there is no way to getting something new, right? So, but here what is happening? So if I want to find out the BFS tree, so it's actually becoming a single line path type of graph, right? So that's the difference between BFS tree and DFS tree. You can easily.
Ma'am, in this TFS, we don't have to backtrack at all, right?
Yeah, backtrack. So see, here we don't need to backtrack because at every stage I have something new to explore.
So it will be like
From
opposite
9
9, 8, 7, 6.
No. For backtracking, we don't have to consider in the trees, right? We don't have to mention in the trees. In the tree, we just put an arrow where we are exploring. That's it. If you are backtracking, then we won't put the back arrows. Then it will create a cycle now. So what is a tree? So T is a recycling graph.
Ma'am, like in DFS, first of all, like in the first step, like we'll consider the neighbors of one, right? First of all, we'll list down the neighbors and then we'll take the neighbor, right?
See, that's a whole DFS process. There you have one stack, one column containing vertices, one true false entry and all these things, right? Here I just want to find out the BFS tree. So here I'm not listing all the neighbors and then picking one, then listing all the neighbors, then picking one. Here I'm just going via random, right? So I can take one. You can consider any neighbor of one. It's up to you, right? You're getting my point, right?
Ma'am, do they ever ask the numbering that we do in backtracking process?
That pre-number, post number, they won't ask you particular numbers, but they will ask you about forward and backward edge. So for that, I think you should consider this number. Okay, so if you want to see,
Ma'am,
if
can
you
you
have
take a
any
look
doubt,
at the activity question, ma'am? BFS and
activity
DFS application.
yeah, you can. I will take the activity question at the end. Okay, I just have to cover 4 to 5 main algorithm. That's all.
Okay, ma'am. No, I just thought it would be appropriate to explain at the moment.
Yeah, we can. For that, I also have to.
Ma'am, in the DFS, the stack would be 3 to 8. 1 to 8.
Yeah, the stack will be from
1 to 8.
whatever remaining vertices are. And I mean, if you particularly apply all the chains, I mean, if you consider the stack, that will contain all your vertices.
Ma'am, could you please explain how the BFS tree can be written in that single line that maybe has some of the.
See, what does DFS do? DFS work like first you consider the vertex, then you choose its neighbor. If it is, if that particular neighbor is giving you something new, then you will consider that new neighbor and explore your vertices, right? In BFS, what we have to do, we have to stick to one vertex and explore all those neighbors. Here, what we have to do, we have to jump to
That
the
I could understand, ma'am, but what the thing is, we want to write the order like 1, 6, 4,
No, it's
3,
not
like that. It maybe
you can write any way, any vertex you can choose. I am choosing 1 to 3, but you can choose since one is having 3 vertices, right?
For
3
example,
neighbors.
if I am saying 1, 6, 4, 3, and then 10,
6,
7,
no,
9.
you can take 4. You can't take 4 now. 6. We have
I mean,
to consider
BFS we can
neighbors of
take,
6 then. In BFS, you can take, but BFS won't work like this.
I'm asking about BFS only, ma'am. BFS, if you want to write that
You're asking about
order
BFS.
of numbering, BFS, breadth first search.
Okay.
So how
So
can we write that order in linear?
This order, 6, 4, 3.
Yes, 1, 6,
You can
4,
take it to be 4, 6, 3 or 3, 4, 6, anything.
3, 4, 6 like that. And then in the bottom portion, the 10, 7, 9, 2, 5, 8 can be on any order, or it will be like 7, 10, 2, 9 and 8, 5 like that.
See, they are ordered only because of they are neighbors of the upper one, right? The 6, 4 and what the vertex is 6, 4, 3 is actually the parent of these vertices. So you have to assign them choose the parents in any order. So I'm taking 10 and 9, you can take 9 and 10. But you can't shuffle 5 and 9. Okay,
Oh,
because
okay.
5 will have parent 3.
That's what
and
I'm asking, ma'am. Well, because like A, B, C, D, E, F, if they are giving that, they will give some order like A, like that B, C, like D, E, or E, F.
Huh.
Whatever the possible options can be choose like that, they will ask. So that I want to order these pairs. If this is also correct, and that is also correct, like that it may be. So
See, we know that BFS tree is not unique. You can order them in your own way, but they will ask possibility, right? So you have to consider which are the tree can be possible as a BFS tree. So you have to consider that since we are making such kind of things. So there is switching possible between 10 and 7, not 5 and 7 and 5. So in some tree, if they listed 5 and 7 together, obviously that particular tree can't be an option, right? So you have to guess which tree can be a BFS tree.
what shall I say the answer? Whether you can tell me whether it is I'm right or wrong. That is one. If I am choosing 4, 3, 6, then I have to say 9, 2, 5, 8, and 7 and 10. And that is in the linear way I am writing, not in the graphical way.
Yeah,
If
you
I'm
can
writing
say
the linear
that's
way.
also fine.
Like that.
That's also fine because
It's
all
a-
are satisfying.
What the thing we are taking, we have to write that to be in the coming next step, right? Could you get me what I'm asking?
I mean, you want to know that we can change these two things or not, right?
These two things.
7,
That
10
means
or
if I am
yeah, you
taking
can
3,
change. Obviously, you can change.
if I am taking 3 first, and then next will be 4, next will be 6. I have to write only that after the tree which comes next to 3,
See,
5 and
this
8,
picture
not
matters to
9 and
us.
2 like that, right?
Yeah, right.
Yeah,
This
that's what I'm asking.
picture mattered to us. That's all. And all the vertices which can sit here, which can sit here, and which can sit.
So based on the picture, we have to write the linear term.
Right.
Ma'am,
Yes.
like in one of the previous PYQ session of mathematics, when sir was making the DFS tree, what he did, like first of all, he listed like let's say he started from from vertex 1. Then he'll be writing, he'll be making 3 arrows, and then he'll be listing the neighbors, and then he'll be taking one neighbor, and then he'll explore that neighbor. So like,
That's the thing we are doing here also.
but in this we just took one, and thereafter we started exploring his neighbor.
Because at every stage we are getting new neighbor now. We have to backtrack once we don't have anything new to explore. Then only you have to backtrack. So here what is happening? The graph is connected in such a way that every neighbor, there is one unique unvisited neighbor. So that's why we are not backtracking. We can list out all the neighbors in just a one. So we have to backtrack only when we come across such a situation where there is nothing new to. Okay.
No, ma'am, I'm not
Then
talking
only we
about
have
that track. Like I'm talking about like in the initial, let's say on the first level, in the DFS, there will be 3 edges from one, or there will be single edge.
There will be 3 edges from one. Why there will be single edge?
Ma'am, in DFS.
In DFS, yeah, there will be single edge. I mean, I just wrote it in the horizontal manner. If you take it to be vertical manner, then there will be a single edge. I'm not getting your question, although. I mean, you are asking about this particular thing. No, there should be a single edge. 1, 2, then 3. This will be our DFS.
But there will be like there's one more neighbor of 1, so like 4, let's say, or 6. So there should be one more edge, right? I mean,
no, there should not be one more edge. See, that's the difference between BFS and DFS tree. BFS tree will list out all the neighbors according to the level. DFS tree won't say anything about level. Just say explore one vertex. If you are getting anything new, just go to that vertex and explore that their neighbors. Since 6, I have 2 new vertices, 7 and 2. So I'll go to 7. Why should I have to take this and make it to be 3 or something? I can't do that. I can't backtrack until and unless I don't have anything new to do. See, if you want to make a branch here, you have to backtrack to 1, and then only you can make a branch, right?
okay, ma'am, now got it. Okay, ma'am, please take one question about it and the end, ma'am.
Take one question on what?
Ma'am, one question about DFS in the end, if you want.
I think the tutorial
Yeah.
video week 10 it's available.
And
I'm telling
also, I mean, I took at least an hour to define BFS and DFS
Yeah,
in
you can
last.
see the solve with us session. There also they take this type of
Okay,
question.
fine. So there is one question here asked by Vaikunth. Okay, so in this question, BFS tree is given, so everyone can see that particular question, right? I just want to give a hint about this particular question because such type of question only can form using BFS and BFS tree. Okay, so here it says that suppose we obtain the following BFS tree rooted at node A. So again, the root will always given to you. So here the root is A, and it's given that it's a BFS tree. It's not a graph, it's a BFS tree obtained from some graph.
Where is the question?
It's on the chat box.
Okay, thank you.
Yeah. It's in the chat box. I'll also pin it if possible. Okay, fine. So this question simply says we have to answer that which of the following cannot be an edge in the original graph. Now assume that there is an edge between A and E. Okay, the vertex number A and the vertex number E. Okay, so if there is an edge between A and E, then E will be a neighbor of A. So that means E should be listed in level number 2. But what is happening here? Because this type of question only these are important questions for point of view of BFS and DFS. So here.
Yes, ma'am, there is the key point that if the level of I is equal to
See.
I plus 1, the maximum.
Right. So this level will contain all the neighbors of the vertex number A. Okay, and this level will contain all the neighbors of B and C with the respective edges. Okay, so that means if there is an edge between A to E, then E should listed in the level number 1. So we consider 0, 1, 2, 3 as the levels. So if E and A are the neighbors of each other, then E should be listed here, not there. So that's why which of the following cannot be an edge in the graph. So A and E can't be an edge in the graph. Similarly, A and D also can't be an edge in the graph. A and F also can't be an edge in the graph. But B and C can have an edge, right? Because they are listed over the same level. So it is possible to have an edge between B and C. Okay. Is that fine? Everyone.
So edges will be only possible between in BFS tree.
Same
Edges will be
level
only
questions.
possible with same level.
Same level or
I plus 1.
Only same level. That's
I
Ma'am,
plus 1.
Ma'am, it's
thank you, ma'am.
only it's possible for same level and for also I plus 1.
See, if there is an edge between A here, B and D, if there is an edge between
if that
B
is
and
possible,
D, then
that's
we
I
will
plus
list. We can list D here, no?
Yeah.
We won't list D here. Because
Yeah.
first we will explore B and then we will explore C. I mean, it depends on the tree, whatever T is given to us. But although if someone asking about the edges, they also ask about the 2 level difference, either 0 to 2 or 1 to 3. If there is choice of vertices which lie in level 1 and the another one is lying on level 3, then obviously there can't be an edge between them. Okay, so that's a very feasible question. Between these two level, it's actually depend on the graph and depend on the person who made this tree. Okay.
Between B and C, how it is possible?
Why can't it possible? B and C can be adjacent to each other, right? If we consider the graph, same tree, consider the graph with same tree and just put an edge between them and find out the BFS tree of this graph. You will get the same graph.
Ma'am, so for B, vertex B, there are edges like BE, BC, AB, ma'am.
AB is the edge. You can consider it. Okay.
Ma'am, if B and C are connected means then it can be C can be next level of B, ma'am.
Why is this so? first we will list it, since C is a neighbor of A also, so C will be listed now. If there is an edge between B and C, then the neighbor of A will list B and C. So why we will list C here? C is a neighbor of A, so C will list here only. C will list at the level number 1. Okay.
Okay,
So I'll
ma'am.
just
So what
advise
if
you to just go and check the once again the BFS. See how
yeah,
it
ma'am.
will
What if they ask for DFS, ma'am, in the same graph, which edge will not
DFS,
be
you have
there?
to apply the logic from the DFS. In DFS, we don't have particular levels and all. So there will be little bit tough to see which. So see,
Can we
whenever
go with
such
the
type of
algorithm?
question will happen now, see, whenever such kind of question will happen now, so what you will do, for example, in this case, they ask that, is it possible to have an edge between something E and A, right? So what you will do, you will make new graph. If you are getting confused that my answer is correct or not, so what you will do, make the new graph, use the same tree and just assign an edge between these two vertices. And now find the BFS tree of this particular tree. Okay, so then you will find out that this tree won't.
Okay, ma'am.
So this is the one cross checks you can do.
Okay, we can reverse solve.
Sorry, what?
Yeah, we can reverse solve, ma'am. Thank you for that.
Right, it's some kind of reverse.
Ma'am, what about DFS tree? Like, how can we understand that it is
Just
disconnected or
use the
not?
logic what we are using there in BFS. I mean DFS tree. What are the properties?
It's the same logic.
A DFS tree. Same. You can't apply the logic of level.
Ma'am, I guess
Don't
the
do that,
different
please.
branches, ma'am, the different branches,
Yeah.
no elements in different branches cannot be
Oh,
connected. That type of.
Yeah,
Okay,
yeah.
Right. That type
It
of
was
thing
there
will
in
be.
the revision session, I guess.
Ma'am, I have a doubt, ma'am. Suppose if vertex A is branched to B, so is it that B has a edge to A? Can you reverse?
I'm not getting your question. You can ask in Hindi if you are not comfortable.
No, ma'am. Actually, here it is. Yes, that's actually here. A is branched to B and C. Now, what's my question is, if they're asking where and all B has its edges, so it has edges in BC, then BE, BD, AB, ma'am.
See, whatever edges is given in the graph, obviously given in the tree, those are obviously the edges in the graph itself.
Okay, ma'am. So, thank you, ma'am.
Okay, so now let's
Ma'am,
go toward.
ma'am, one last thing, ma'am, please. Someone posted that question, DFS question, ma'am, in the chat box.
Okay, Jayashree, I think.
Yeah, ma'am.
Now you guys will answer about this question. So I'll ask one by one. Right. So in this question, it's a DFS tree, first of all. It's a DFS tree, and which of the following cannot be an edge in the original graph? Okay. So can B and F, is there a,
First
I
of
mean,
all,
it is
divide.
possible to have a.
Ma'am, first of all, divide this whole DFS tree into branches, like A, B, and DF, one branch, A, B, and E, the second branch, and A, C, and D, the third branch. If 2 points are the same branches, then we can say that there is an edge between these two vertices. Or if not in the same branch, then there is not an edge.
Correct. So whatever he is saying, that's only the process. So here there is possible that we can have a edge between B and F, because certainly F is belonging in the branch of B. So yeah, so it is possible to have a edge between
Backward
B and
edge.
So that means that's not correct. Now again A and G. So again it is possible to have an edge between E and G, because again they are in the same place. So that means this is not right. Now E and F you consider. So this is E and this is F. So suppose there is an edge between E and F. So then what happened? Once I reach to F, because see, BFS tree will say that you have to start from A. After that, I'll move to B. I'll move to E and I can backtrack and then go to D, go to F. This is a one possibility can happen. But since D is listed ahead of E, so that means the BFS tree is working in this manner. The first vertex is A. Second vertex, I am going to B. Third vertex is D. And the fourth vertex is F. Now, if suppose there is an edge between F and E, then the E should come at the fifth number of vertex, not here. So that means there is not an edge between F and E. And another thing is they are belonging to different branches. So that's why there can't be an edge between E and F. So this is a correct option. But again, A and F can have the edge because of the same reason. Okay.
It's an cross
Is that
edge.
fine? Yeah. Is that fine for everyone?
Yeah, ma'am.
Yes, ma'am. It's fine. The parent is different for that case.
Right. So those things are fine. Now, topological sorting. Are you guys familiar with topological sorting? It's a pure,
Yes, ma'am.
basic
Ma'am.
algorithm.
Yes, ma'am.
Ma'am, in degree 0, then you need to remove that point and
Ha,
update all the time.
right. So I'll
Yeah.
briefly inform what is the thing. So first thing
Just
is,
longest
one
path.
thing. Ma'am, did you discuss on
yes,
this non-tree edges? Ma'am?
non-tree edges, forward edge, backward edge, and so on.
Yes, ma'am.
So see, those are actually depending on the DFS numbering also. And there is one particular definition, so that if U and V have same ancestor, then if U is an ancestor of V, then there is a forward edge from U to. Now, if V is an ancestor of U, then there is a backward edge from V to U. And if U and V does not have any common ancestor, then these two are, there will be a cross edge between U two. Okay, so this is a one definition related to ancestor and all. So I cover that in also in my previous lecture, you can check that. But although if you want to answer the forward edge, backward edge question, then you have to go via the DFS numbering. First, you have to answer the DFS numbering, what are those, and then you have to go to the
Yes, ma'am.
forward
If suppose they are given a graph, and from that graph we are drawing a DFS tree, in that case, then we need to see that there is an from the graph the edge between any two vertex and draw that like 1 to 2 there is an edge. So in the DFS tree we need to do there is an edge from 1 to 2 vertex. So we can from that we can say that there is an backward, forward, and cross edge.
Yeah, you can use DFST also. That if graph is
Yeah.
given to you, just extract the DFST, and if
Yeah, we
such
need
kind
to
of
use
edge is
DFS
there,
tree.
it's
After
backward.
that, seeing that graph, there is an edge, direct edge, or non-direct,
Yeah,
direct
you can
edge.
see all those things.
Like,
Okay, so topological sorting is okay, I hope. And after that,
Ma'am.
the longest path is also fine because these two are
Ma'am,
the same.
you will cover
Yes.
week 11 also, ma'am, fully.
Sorry, what?
Will you
week
cover
10 and
week 11
11.
also?
Yeah, see, week 11 actually have, I'll discuss the main concept, what are the main algorithms are there. These I will discuss, mainly I'll discuss Descartes algorithm, Prim's and Pushkal's algorithm. These three are main. Although if you want to
Okay.
revise the remaining algorithm, you can check the previous week video. There I discussed all these algorithms very deeply. Okay, because we don't have
Is it,
time. If I
ma'am,
want
excuse me.
to, yes.
Is BFS, does BFS always give the shortest path of the,
BFS give the shortest part, DFS won't give the shortest.
yeah, of course.
Because of the example, that particular Peterson's graph we saw. DFS
Yeah,
just giving
DFS
us a
uses for
one straight,
reachability.
right? DFS uses for reachability and for answering if there
Connected
is any cycle
and
or not.
cycle like this.
Okay, so let's go to the Descartes algorithm. Okay, so Descartes algorithm actually give us the shortest path, single source shortest path between any two vertices in our particular graph. Okay, so I'll take the same question, whatever discussion we, or if you guys have any question related to Descartes algorithm, you can post in the chat. We can discuss that. Yeah, you can, if you are having doubt in topological sorting and longest path algorithm, you can check the last week's video. There we discuss these two concepts very well. Anyone want to ask any question about Descartes algorithm?
Ma'am, there is a question I think in the graded assignment or practice assignment. They are finding the value of x for which the path will be minimum.
Minimum.
The length of the
Shortest
path will
path
be
we have to
minimum.
answer.
Yeah.
Right. So here what happened, I'll just take the same graph. Someone posted something.
Ma'am, that's thing is clear to me for this algorithm.
Descartes algorithm.
But like in the negative edge, we are using the new Bellman algorithm. In that case,
See, Bellman-Ford algorithm is very tough to apply, and it is not possible to apply that algorithm within 30 minutes although, right? So obviously no
ma'am.
one will ask any question from
Like in the graded assignment 11, like there is a question topological sorting. So in that case, it is
Yeah.
also not possible drawing
Yeah,
all the
correct.
step like.
Because these are algorithm we are teaching you because I mean in the future you have to make some programming, right? So in
Yeah.
programming these algorithm actually will have. So that's why we are teaching. Although obviously we can't ask anything about from Bellman-Ford algorithm
Yeah,
because
it
it
takes
will took half
15
an
more
hour.
than 15
So
minutes.
how can anyone answer, right? So
Yeah.
although we can ask conceptual question, that means Bellman-Ford algorithm used when we have negative weight,
Negative
right?
edges and
And
it
when
can't
we
use
have
for
to solve
a negative cycle.
right, not containing negative cycles and for single source shortest path, right? So
Yeah,
these
to find a
theoretical
negative
question
cycle.
can be there.
Ma'am, I am thinking that if I'm right or wrong, I am that if there is an n number of vertices, so we need to do the n number of iteration for the new Bellman-Ford algorithm.
Right.
If there is
And
a
at the nth
more
stage,
than
you will find
n
out
number
the
of
answer.
iteration that's going on, then we can say there is a negative cycle in that case. Because every time we are
If
getting
right,
that
right.
negative shortest path, so there is a negative cycle in that case.
If in the okay, so there is one question to us. Let's go with this. Okay, I'll answer the Shivam question. Okay, so let's just simply understand what is the Descartes algorithm here. So Shivam, is this Descartes algorithm questions or Prince and Mushkil's? It's Prince and
It's not my doubt, ma'am. I didn't ask him. This course is clear to me.
Okay, fine. So I'll use this particular graph for Prince and Mushkil's. Okay. So just understand Descartes algorithm here only. So Descartes algorithm argues that if you want to find out the minimum distance from a particular fixed graph to any other graph, from a particular fixed vertex to any other vertex in your weighted graph, which does not have any negative cycles or any negative edges, right? So Descartes algorithm actually used for two things. First thing is it will answer the single source shortest path problem. This thing you have to remember that which algorithm is used for which thing and what are the restrictions. Okay. Second thing is there should not be any negative edges / cycles. I hope you guys are familiar with negative edges and cycles. Okay. And the third thing is the third thing it used for weighted graph. Weighted graph means there should be there is a weight between there is a weight over
The edge should we have value.
So suppose we have to apply this Descartes algorithm over this particular graph. So what we will do, so we'll start with any vertex. So as usual, start with the vertex number 0. So initially every vertex from 0 will have infinite distance. That means this since we haven't started fire at the vertex 0. So you can understand with the fire that whatever situations are happening, that if we burn this vertex, then fire will start spreading in this direction and this direction. So according to these numbers, we assume that this rope will have actually length 10 meter or 10 centimeter. This rope will have length 80 centimeter. So obviously fire will move in this direction rapidly, and we can that the burning time of this vertex particular one is nothing but 10, right? Now again, fire can reach vertex number 2 at by covering this particular edge and this edge within the 16 distance, because obviously this distance is 80, and as we consider the 16, fire will reach halfway only, right? So that's why the distance of this vertex from 0 is nothing but 16. Now in the second step, the fire will move around this direction and along this direction. So here it's 70, so it will reach vertex number 3 very late, right? So these vertices are not bound. Now it can reach the vertex number 4 after covering this 10 distance and 20 distance. So that's why the distance of vertex number 4 will become 30, and this vertex will be born after covering this 30 distance, right? And so far fire will reach here. Now again, as you move along, fire will start running in this particular direction using this particular edge with weight number 5, right? Which has weight 5. And here also it will start spreading toward this direction, which has weight 50. But obviously it will reach using this wedge to the vertex number 6 very easily. And the distance from 0 to 6 will become 30 plus 5, 35. Okay. Now again, fire will start spreading over all the directions. So it will reach the vertex number 5 at the distance 35 plus 10, 45. And at the distance 3, because since we don't have any option to take this particular edge 70. So 16 plus 70, 86. Okay. So that's how Descartes' algorithm works. Is that fine? Any doubt in Descartes' algorithm?
Ma'am, we can use also that minimum spanning tree concept here. That is the
But-
another way to find that shortest distance from the zero vertex,
Yeah.
every other vertex.
Minimum spanning tree. Yeah, first you will consider the spanning tree and then you will consider the minimum
Yeah,
distance. That's your
spanning tree,
strategy,
then
right?
we can count the distance like 80 plus 10, 90.
Yeah. So that's also you can do, but this is a general process of Descartes. So you can apply Descartes. Okay. So now there's one graph. So I'll share my screen.
You
using-
just shared on something.
Sorry.
Ma'am, actually you shared a white screen, no, ma'am. Just like you just pointed out every weights of the edges. So in that, sorry, ma'am. Just got sorry.
Okay. So now here there are two questions, question number 15 and 16. And here we have to find out minimal cost spanning tree. So what is a spanning tree? So spanning tree is nothing but a tree in a graph which will cover all the vertices. Right? It's known to be a spanning tree.
Ma'am,
Yes.
can you explain Floyd-Warshall algorithm after this?
Floyd-Warshall algorithm, yeah, but again, that's also a bit complicated, right?
Okay. Ma'am, actually, I cannot grasp that algorithm because I've gone through the lectures, but I have some difficulties in that understanding in that algorithm.
Okay, I'll discuss Floyd's. But see, that's also in that algorithm, we have to move step by step, right? First, we have to find out all the possible, it based on successive, what you can say successively, we have to do that particular steps, right? We have to find out a path considering some particular vertices, right? That's the Floyd-Warshall. Okay. So first I'll
Ma'am, actually the previous question, we didn't find the shortest path. We just pointed out the weightage, ma'am.
We pointed out the minimum distance from the vertex 0.
Oh, 0 to 7.
Yeah. 0 to every vertex. Every other vertex.
Okay, thank you.
Okay. So now spanning tree. So for spanning tree, we have two algorithms. First is Prim's algorithm. Second is Pushkal's algorithm. Okay, so Prim's algorithm says that if you have given a weighted graph, then choose the minimum weight edge in the explore your graph. For example, here in this particular graph, the minimum weight edge is this edge, right? So I'll consider my tree to be, I grow my tree in this one. I'll consider these two vertices and this edge. Now Prim's algorithm says that add all those edges which are minimum weight and which won't create a cycle. So what we have to add? We have to add all edges which won't create cycle and minimum weight. Right? So from here one, I have two choices. I can add the edge with the weight 3 and I can add the edge with the weight 2. So again, I have to consider minimum 1. So I'll consider the edge which has weight 2. So it will be 3. Okay, let consider any other graph. Okay. Okay, fine. We can consider the same.
How did you get this one, ma'am? This is my image. I told you.
Sorry, what?
Ma'am, from where did you get that image?
This image shared by Shivam. Yeah, Shivam, where did you got this image?
That is on my man. I solved it.
Okay, that's yours. Thank you. Okay, so since we are all halfway through this question, so let's complete it.
This is easy.
So
ma'am.
yeah.
It is
Huh,
mock
it's
question, ma'am.
easy
I think it will be discussed in mock.
Okay, is it a mock question?
Yes, ma'am.
Yeah, it is a mock question. I thought it's the previous term question or something like that. That's why I say this is a very familiar question. So again, Prim's algorithm, what does it say? So it says my screen is visible, right?
Yes, ma'am.
Yes, ma'am.
So Prim's algorithm says took the minimum weighted edge and explore your graph. So here I can consider the edge number 3, edge which has weight 3 because it will create a cycle. So I'll consider this edge with weight 4, connect the vertex D. After that, I'll consider the edge with the weight 5, connect the vertex E. Is there as well? Okay, and then I'll take edge with weight 7, connect the vertex F, and then I'll consider the edge with weight 9, connect the vertex number, vertex G, and after that I'll consider the edge. You can consider any one of them, both have same, what you can say, same weight, right? And connect the E edge. So if you add up all the quantity, it will become 13. So the answer is correct, it's 13. That's the Prim's algorithm. Similar problem we can address via Kushkal's algorithm also. But Kushkal's algorithm says that first consider all the vertices as disconnected components and then add edges which are of minimum weight and won't create a cycle. Same restriction. Okay. So first I am considering all the vertices as my disconnected components, and after that I am adding edges. Okay. So these are the edges I can add, which won't create a cycle and give us a minimal cost benefit. Okay. So this the same tree we can obtain. Is that fine? Any doubt in these two algorithms, Prim's, Kushkal's?
No.
Now let's go. One thing I want to discuss is there are so many algorithms, right? So let's at least list out some of them. So first thing is Descartes' algorithm.
I have a doubt, ma'am. Dijkstra's algorithm, in that for finding shortest distance, we have to visit every vertex, or is it okay to visit some along?
No, see, Descartes' algorithm will give us the shortest distance from vertex 0 to every other vertex. So if they say that apply Descartes' algorithm and find something, so you just apply Descartes' algorithm and find all the distances.
So it will be covering every vertex, but okay, got it. Thank you. But span is okay.
Sorry?
No, ma'am, I got it, ma'am. Thank you.
Okay, this thing I already tell that no negative edges, right, or cycles. Then after that, for addressing, oh, sorry. This thing I already told you. And the second thing is for addressing this problem, that if we have a negative edge, then we use Bellman-Ford algorithm. Right? So Bellman-Ford algorithm is also used for single source shortest problem with negative edges. But no cycles. Right? If there is a negative cycle, then we can't get our conclusion using Bellman-Ford also, right? And after that, we have fluid washer algorithm, which address with all pair shortest, right? So all pair shortest path,
Will
if you want to
questions
find, you
related
will
to
apply.
the Dijkstra or the Bellman-Ford algorithms, will they come in questions?
It's very tough to ask a question from Bellman-Ford algorithm because at the end stage only you will get your answer. Similar thing will happen with fluid washer algorithm. At the end only you will find answer. They can ask about SP1 and SP2 at max, right? But again, if you want to answer SP1, you have to compute so many entries. So
It is
I really
huge
don't
task.
hope so. They will ask about SP1 either. At max, they can ask about SP1 that find the what is the weight. Sorry, what?
What is SP1 and SP2, ma'am?
SP1 actually a matrix in such a way. I mean, if you go through the
Ma'am, please,
Bellman-Ford algorithm.
ma'am, please
So-
explain SP1 and SP2 with one small example.
Okay, see. So what is SP1? So SP1, if you have n vertices, so an SP1 is nothing but an n by n matrix, right? In such a way that SP1 of ij, so that means the ijth entry, it's equal to 1 if there is a path, there exists a path between I and j using vertex 0 to 1, right? This is the SP1. So that means you have to move from the vertex I and j using these two particular vertices, the vertex number 0 or the vertex number.
So SP1 is just the matrix, the adjacency matrix.
It's a matrix
And
only.
SP2 is
Type of,
using the path, two paths, like for the paths
kind
with
of
two
a
lengths.
thing. Yeah, you can say that because
If the vertices start from 0, then 0
Then,
is like use the intermediate.
If
Yeah,
SP1 is a
that's why
matrix, if
This
SP1 is a
is-
matrix, then SP2 is a cross A matrix, right?
no, SP1 is again a matrix, SP2 is also a matrix, but there, see, that's why I'm telling you that here we just have to use one second.
Ma'am, one will be an intermediate, right?
If we are starting with 0 or something, then it will be the case that 0 is only there. I'm just checking that 0 is correct.
Ma'am, sometimes I have seen the matrices like SP0.
Yeah, it is
SP0
it
is
is
the
nothing.
only weight. There
It
is
is the
nothing,
initial
just an
matrix.
adjacency matrix.
Right?
Yeah, just the adjacency matrix.
Oh, but I mean,
correct.
sometimes the index starts with 0 and sometimes with 1.
No. See, SP0 is nothing but the adjacency matrix.
Or is SP0 same as SP1?
No, SP1 is actually that SP1 will have entry 1 or whatever the weight is present there, that particular weight. If there is a path from I to j using the vertex 0. So that means if this is a vertex I, this is a vertex j, then you have to find a path in such a way that includes this particular vertex 0. So that is SP0. SP1.
Sir, ma'am, or I can say that SP1 means there is one element.
One element,
Yeah, the
that
first
is a
element.
fixed element. You
Yeah,
don't have to
like
consider
SP2,
any
you
other
can say
element.
that there is an
Zero
two
is
element
fixed.
that like 0 and 1. If it's starting vertex 0,
Correct. So that's
like that
the
you can
thing.
remember that. There is no connection
ma'am,
in the vertex 0 and 1.
Ma'am, we do these problems by multiplication of matrix, right?
No, this problem
For
can't be
that,
addressed
we
by
have to first
multiplication of
calculate SP1 and SP2. Then we can do the multiplication.
Then you can do the multiplication. For SP0, SP1, you just have to simply address the following connection, right? So SP1 is again n cross n matrix in such a way that the ijth entry is your weight if there is an edge from I to j using the particular particular vertex named to be 0. Okay. Otherwise 0. And SP2 is again the same thing. It's again an n cross n matrix in such a way that again the weight will be there, 0 will be there. If there is a path from I to j using the vertices 0 and 1. So here you just have to consider 2 vertices. And there is a particular relation between SPK plus 1 and SPK. So that is this your SPK plus 1 of IJ.
I couldn't
You can
understand
describe
the graph here in SP1. What do you mean by
Ma'am,
I then crossing 0 then J?
I mean, there should
ma'am,
be a
the
path between I
value
to J
of
including
W
0.
will be,
Weight of the H,
ma'am, how do
whatever
we
weight is there.
calculate the value of W for SP2 and SP1?
The weight of the graph, I mean, see, if this is a path, then what is the weight of this path? 10 plus 1, 11. That's how you calculate.
Okay, so we
Ma'am,
have to add those weightage.
Add those 4 weights.
ma'am,
Ma'am,
in SP2,
if we
we
are
can
going
either
like
use
this,
0
I
or
don't think
1.
so that we can.
Just put 1 by 1.
Ma'am, in SP2, we can use either 0 or 1, or we have to use both 0 and 1 when we are moving from I to J.
See,
In
weighted
SP2.
graph is there, then you have to you have to use your weight. And if weight is not there, then use 0 and 1. If the path is there, then use 1. Otherwise, C. Else.
We have to use both 0 and 1, or either 0 or 1 in SP2.
So at one particular entry, you can either use 0 or 1. But overall, the metrics, you have to use 0 and 1 both quantities.
Ma'am, actually, I have a doubt. This was discussed in some revision class, TA section. So in that, they gave a formula like longest path equal to maximum of longest of u comma 1 plus longest of I. I don't remember what's that concept. Can you please explain?
I also won't understand what you're saying.
Longest path equal to maximum.
Okay, longest path problem. Yeah. So longest path is what? If you want to find out the longest path to any vertex, suppose you want to find out the longest path to the vertex J. So what is the concept? So the concept of longest path is that the longest path of any vertex I is equals to 0 if the in degree of I is 0. Right? And the longest path to any vertex J is actually 1 plus the maximum of the longest path to any vertex K. 1 plus the longest path to any vertex K, where there is an edge between J to K. So that means if this is your vertex J, you have to find out, you want to find the longest path. What you will do, find the longest path to all its previous neighbors. That means K1, K2, K3, K4, right? Find the longest path up to these vertices and just add one more to that particular longest path and take the maximum line. That's the formula. Yeah, Freud-Warshall algorithm is in your syllabus.
Ma'am, in that case, I want to say that for finding the maximum longest path, that vertex we are removing, we need to attach +1 with this vertex.
We have to find out
in
what
the
are the
starting or
longest,
initial
what is
state,
the
all
maximum.
the vertexes has the length 0.
Yeah, that's why we assume this condition, right? Longest path of I is
And
equals
the
to 0 if in
vertex
degree
we are
0.
removing for that, it will increases the longest path for that vertexes
via
that
length
are
1.
adjacency matrix.
So we should add 1 to the vertex, the corresponding vertex, so we can find the longest path.
The longest path. Yeah. Successive
Adjacency
method we are doing
matrix.
something like that.
Okay, ma'am. Okay, so thank you.
Okay, fine. So now let's move toward the mock. Yeah. Any doubt?
Ma'am, I have a
scroll
doubt
up
in
a
graded
bit.
assignment 11 question.
Wait.
Graded assignment.
Can you scroll up a bit?
Yeah, sure.
A little more, ma'am. A little more. Yes, ma'am. 1 second. Yes, ma'am. 1 second.
Is that fine?
Yes, ma'am. Thank you. Yes, ma'am. Thank you, ma'am.
Okay, fine. So now let's go toward the mock discussion. Okay, so I'll ask one by one, whatever doubt you guys have. I'll go through question by question. First question, second question.
Ma'am, I have a doubt on graded assignment.
11th week, no?
Yeah.
And can we first solve the mock?
Yeah, I'm just going toward the mock. Graded, which question? 11th.
Ma'am, mine. Ma'am, I don't remember the question number. If you can show.
I can't show actually. Okay, fine. So what is, I mean, you remember the context, right? So what is the context?
Yeah, I think the question number 2, ma'am.
Of?
Yeah, graded assignment 11.
So let G is a connected undirected graph in such a way every vertex is degree at most 4 and the shortest path. Okay, so try to draw the BFS tree starting with vertex. So here, what is given to you that every vertex is degree 4, right? And the shortest path between any two vertices has length at most 2. So you can use this information. So suppose I want to, and there's one hint is given that you have to use BFST. So I'll start with my BFST with any vertex, name it to be 1. Then A actually having 4 neighbors, right? So let's name them to be B, C, D, E, right? And the second fact says that the longest path or the shortest path between any two vertices has length at most 2. So that means if there are two vertices in our graph, let's name it to be small a, small b, then either they are connected by an edge or there is one intermediate vertex which is connecting B and C, right? So here, if any vertex which can be, I mean, ultimately what is happening that either any vertex is connected to the vertex A or it is connected to vertex either B, C, D, or E. For example, I can assign a vertex F here, G here, H here, G, right? Now, if you assign any new vertex here, so let's say I'll assign new vertex here, that I'll say that vertex number B actually has, every vertex will have 4 neighbors. So we have to just consider 2 things. First thing is degree 4. So that means everyone will have 4 neighbors.
Yeah.
So 1 neighbor is there, so 3 is there. 3 will be there. Right. So now what I want to say that we cannot go further. We cannot cross this level. Suppose this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means we cannot cross more than 17 elements. So if you consider any element, you have to either it will be a neighbor of any one which are lying in the level number 2. So this is level number 2, level number 1, level number 0. So if you want to go further, you have to go to level number 3. But if I will go to level number 3, then the shortest part between this vertex, which is situated in level number 3, and the vertex A will be 3. 1H, 2H, 3. So why using this restriction that the path between any two vertices has length at most 2, we can answer that there can be at most 17 vertices.
Like, ma'am, the answer is given that k square plus 1. Like, k is the
whatever the will be, we can answer it. Is that fine for everyone? I'm discussing the question number 2 from graded assignment. So let's go toward mock. Yeah.
Ma'am, can you repeat this answer? I'm not getting exactly.
See what happened. It says that every vertex V having 4 degree, that means 4 neighbors are there, and the shortest path is
Has
of
degree
length
at
at
most
most 2,
9.
right? So that means any two vertex can be either connected via single edge, or there is an intermediate vertex between them. Right? Either this possibility can happen or this possibility can happen. So if you construct a BFS tree with any vertex, let's name it to be 1. So 1 is actually having 4 names. So that means 2, 3, 4, 5. Now again 2, 3, 4, 5 are vertices in this particular graph. They will have 4 degree. So that means they will have 3 extra neighbors except 1. Right. Now, if I consider any vertex, suppose these are the vertices 5, 6, 7, 8, 9, 10, up to 17. Right. Now, if I consider any vertex, any other vertex than these 17s, then that particular vertex can occur at this level. Right. It cannot occur here because 1 is having 4 neighbors, and I listed all the 4 neighbors because of the 4 degree. Every vertex here also having 4 degrees, so that's why I listed all the 3 neighbors. And also the minimum, I mean the smallest path between any two vertex here, if you compute, it could be either 1 or 2. So that means I can reach from 2 to 5 using this path, right? 2 to 3 using this path, 1 to 6 using this path, right? So that means any vertex, I mean the shortest path of length will be at most 2. So if you consider any other vertex, then the 17, you have to list it over the level number 2. But here, if you list, then the shortest path between 6 to 1 will become, will be more than 3. So that's why the answer is 7.
Oh, okay, ma'am. The shortest path condition is violated. That's why we cannot have.
Yeah, that's why we cannot have.
Okay, fine.
Ma'am, can you see that
one more
activity
conceptual
question
doubt, ma'am, in
11.6?
practice assignment 7.
Practice assignment 7.
Yeah, ma'am.
Yeah, I'll go to that after more.
Okay, ma'am. Okay. No problem.
Yes, Deepak, you want to say something?
Ma'am, 11.6 question number 2. It's a theoretical question.
Okay, so I'll take after mock.
Okay.
So let's go to mock test of pencil. This mock is very difficult or something? Is it very difficult?
The questions are pretty high.
Questions are pretty high. Okay, let's see. So the first question is based on parabola. Is there any doubt in question number 1?
Ma'am, your screen not visible. Questions not visible.
Yeah, actually question. Okay, fine, I can share. Is it visible? So question number 1.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Any doubt in this question?
Yes, ma'am.
Yes, ma'am. I have doubt.
Yes, ma'am.
So, okay, so let's see. So what is the question? That a firework is projected from the lowest corner of the pole of height. Okay, so here the maximum height, which is same as the height of the pole. Okay. So that means this is our pole, and a firework projected from the lowest corner of pole. Okay, so that means a firework is projected from here, the lowest corner, right? And the length of the pole is 15 meters is given to us. And it reaches to its highest point, and the highest length is same as the height of the pole. So that means this highest length is 15th. So the path of firework is parabolic, and it lengths at 30 meters from the launch of the vertex P. Okay, so that means this is the 30-meter distance. Okay, fine. A ball is thrown from the top of the pole which follow the parabolic path whose vertex is at the point of thrown A. Okay, fine. And lands at the distance 20 meter from the ground. Okay, that's also fine. So taking B as the origin, the horizontal direction is x-axis, real direction is x-axis. One answer the question 1, 2, 3. Okay, so first question is find out the curve followed by framework. So this firework will actually follow a parabola, right? So one thing is given to you that the maximum value of this parabola is 15 meter and this height is 15 meter and they want to consider this to be your x-axis, this to be your y-axis. So that means we somehow judge the vertex of parabola, right? So what are the vertex? So since height is the 15 meters, so that means y coordinate will be 15. What is the x coordinate? What will be the vertex if I am considered the vertex is ax square plus bx plus c? And what will be the correct minus b by 2, right? So this is a vertex coordinate.
Okay.
Okay, so this is one information we got. What is the second information? That the path of firework is parabolic and it lies 30 meter from the launch site B. So that means the distance between this point and this point is 30 meters. So I think they already gave us the answer. I mean, the parabola is intersecting over the origin and the point 0, 30. From using these 2 points, we can somehow calculate what are the values of A, B, and C, right? So that means this point is 0, 0. This point is 0, 30. Because they are considering the x-axis.
30, 0.
Sorry. 30, 0. So if you substitute these values, then what happened? So that means ax square plus bx plus c is equals to y if you suppose. So then y is 0 when it is 0. So if I substitute, then c is equals to 0. And what we have, the next thing is, I mean, this is because of the 0, 0, correct? Am I right or no?
Yes, ma'am.
You guys are getting what I want to say, right?
Yes, ma'am.
If you don't understand
No.
any step, just.
I mean, this parabola
Now-
portion, I don't understand now.
This parabola portion is.
I mean, I couldn't understand this.
See what happened. It's given that firework is following this parabolic path, and it's already given that the highest distance is 50. So we know that if you have a downward parabola, it will reach its highest point at its vertex. So that means we somehow get the information about coordinate of vertex. That vertex will have coordinate of the term minus b by 2a, 50. Right. Now the
Yes,
second
ma'am.
thing is given to us that this parabola is actually intersecting over the origin and the point 30, 0, because they're considering us that this is your x-axis, this is your y-axis. Right. This horizontal plane is your horizontal direction is as x-axis, vertical direction is y-axis, and the vertex b as origin. Right. So that's why we get 2.0, 0 and 30, 30. So if you apply 30, 0, it will become 900 of A plus 30B is equals to Z, right? So from here you can get a relation between A and B. So what it would be that minus 30B is equals to 900A. So that means B is equals to minus 38, right? So we get
Okay,
the
ma'am.
relation C is equals to 0, B is equals to minus 38. Sorry,
Oh, yes, ma'am. Yes, ma'am. Continue.
correct? Now,
Yes, ma'am.
yeah, some question will be like difficulty level you can assume same as mock. Or yeah, you can assume same as mock.
Ma'am, the x coordinate will be 15.
Ma'am,
If
I
we
still want to know
substitute-
why are we saying c is equal to 0 here? Because it intercepts as like
It
the
passing through the
perception
origin, that's one.
Okay.
Right, 0,
Ma'am.
0 and 30, 0.
Like in the
Now we
mocks,
have to,
okay, ma'am. Yes, ma'am.
sorry.
Yes, ma'am. Continue, please. Like, how to find the question?
Okay. So now the next thing is given to us something like that a ball is thrown from the top of the pole which follow the parabolic path whose vertex is at the point coordinate A. So that means this is the vertex. So that means the vertex of this parabola is 0, 15, right? And lands at the distance 20 meter from the ground. Okay, so how does this help us?
Shall we use that parabola formula using vertex and A so that we can get the equation?
Parabola formula using vertex means that formula that
y minus k is equal to a into x minus h.
Y minus k is equals to what's
A
that?
into x minus h the whole square.
Into x minus something is there.
H, ma'am, x minus h. H.
And h is the height of parabola.
Yes, ma'am.
Y, h comma k is vertex, no.
Okay, h comma k is vertex. So here we will get x minus, but we want the x coordinate of vertex. So x coordinate of vertex we can find. We have the
15 is
relation
the-
between.
Yes, ma'am.
Ma'am, then how do we find the value of A?
15 comma, but we don't need here the value of A. Yeah, we need value of A. So we have got the value of K. So the vertex is 15 comma 50.
Nice.
Okay, and the C coordinate is 0. Anything I'm missing? Sum of vertex is
We
minus
need to
B
make
by
another
A.
equation.
And we can go.
We can?
We can
We
go
need to make
the
another equation.
excuse me, we can go from the options they have given, so that where we can get that 15 comma 15, that can be a equation of this.
Yeah. See, here also we can go via the option.
Ma'am, we can substitute
Ma'am,
the
rather
value
than
of
the
B there, right? B is equal minus 30 by A. So then we can substitute. So it's
Yeah, we are
minus 30
just
by-
substituting the value of B, this minus 30.
Yes.
So here the only one option is following, now this B1. Y minus 15 is equals to A value we don't know, but we know the format, so we can easily click on B. Correct? Am I right?
Yes, ma'am. Ma'am, one more doubt. Like in the mock, the majority of questions are from like
Ma'am,
algebra
how
portion.
you calculate the value of A? That's minus 1.
I don't think we have information about value of A because this second information is not seems that good, right? I mean, we have the information that the vertex coordinate is 15 comma 15. We have
Okay,
the
like in
information
the
that C is equals
depend
to
on
0.
the coordinates, like 15, there is a x value of the 15 and the y is maximum.
So yeah, I mean,
Okay, ma'am.
at vertex only we have the maximum.
We can do the max option elimination here.
So via option only is possible answer is B. So I think via options only you have to answer it.
How did you choose the option B? I'm not able to understand that because I solved everything and then did.
So have you got the
we
value
can
for A?
actually get half of the
Yeah, I
answer
need
and then put the A value with the option.
See, we are getting that this is a vertex coordinate. We are getting that C is equals to 0. So that means what is the equation of parabola? So equation of parabola is y minus k is equals to A times x minus h the whole square plus, this is the equation of parabola via the vertex, right? Someone says.
Yes,
Okay, so
ma'am.
if you put the vertex here, it will be y minus 15 is equals to A x minus 15 the whole square. Now, no other formula will reaches at this quantity. This is y minus 30, something like that, something like that. Only
So you
this
just
will have
eliminated
same
that.
format.
Okay.
Ma'am, the only thing we weren't able to find was the value of A, right?
Yeah, I don't think we can find the value of A using the same context.
Ma'am, if we substitute the 0, 0, 0. Yeah, for finding A, can we substitute, I mean, it is 30, 0.
See, we got this. Yeah, here also we can substitute 0.
Yeah, x has 30 and y has 0. If you substitute, you can get
Again,
A value.
right,
Get the
right.
values.
Correct. This is the parabola equation we got. Again, we know that it goes via the 0, 0 condition. So that means y minus 15, 0 minus 15 is equals to
Yes,
again 0
ma'am.
minus 15 square.
Then we got A
So that
equals to
means A is
minus 1
equals
by
to
15.
minus 15, 1 by 15, minus 1. Right. Okay, good.
Ma'am, how did we get
Any-
15 for the vertex? 15 so the y I understood. So the x, how do we get 15?
We uses the two conditions now. We uses the condition that
substitute.
my parabola is passing through 0, 0 and 0, 30, 0. These 2 points, if we use on parabola ax square plus by square plus bx plus c is equals to 0. So you can find out the relation between a and b and just substitute in the vertex minus b by 2. We will get it. Okay. Fine. Session tomorrow, it's already 10. Yeah, I know. Let's see, I'll go up to 10:30 or maybe 10:45. Okay. So let's see how much we can count. I won't rush up because it's important to understand. So this question is clear, right? You just have to go back and forth, whatever thing is there, you have to use it. Right?
Yes, ma'am.
Yes, ma'am. Now, second question says find out the equation of curvature followed by ball. Okay, so here, what are the information we have? That first thing is that this, we have all the information here also. Here
Yes,
only we
ma'am,
have the
yes.
coordinate of vertex. So 0, 15 is the coordinate of vertex, right? 1, 0 is 0, 20, 20, 0. And the another 0 will be, obviously this is symmetric. Parabola is always possesses symmetric behavior if its vertex around the y-axis, right? So the another 0 will be minus 20, 0. So using these three information, you can easily answer what will be the equation of it, right? Correct?
Yes, ma'am.
So let's discuss
Ma'am,
one or two
actually,
questions. Yeah.
Ma'am, question
you know,
number 3.
Yeah, you can go ahead. Now, if both the tasks are performed at the same time, find out the horizontal distance of meeting points from the pole. So see, here you got the equation of parabolas. You just have to find out the point of intersection. Okay, so just equate these
Yeah.
two parabolas.
Equal.
Equate all the two parabolas and find the intersection. That will be your answer. Right.
Ma'am,
So
can
here,
you solve this question, ma'am? I got wrong in that question.
okay. So see, we have two parabolas. So I'm not completing the equation of parabola. So
I
two
don't know where
parabolas
I did.
are.
For second one, last one is the answer.
So it's minus 15, x minus 15 square plus 15 is, I'm just equating two parabolas. Okay, so it will be 15 minus 15 by 20 square is there. So this plus 15 will get cancelled out. This minus sign will get cancelled out. So it will become simply x minus 15 square is equals to 15 square upon 20 square x square. So you can translate here. So it will become x minus 15 square minus of 15x upon 20, the whole square is equals to 0. Correct? And here you can use the formula a minus b plus b. So it will be
Ma'am,
minus
where
15x
did
upon
the
20.
denominator go? Minus 1
This
by
denominator,
15.
this it go up to right hand side 15 square.
Okay, ma'am.
Yeah. X minus 15 plus 15 x by 20 is equals to 0. So that means what we get LCM to be 20. It will be 20x minus 15 into 20 and minus of 15x, right? And same thing. Now it's okay, right? I just created two factors, so you can solve it.
Okay,
Is it
ma'am.
fine?
Okay, ma'am. I left that 15, ma'am, so that only I didn't get that answer. Thank you, ma'am. Thank you so much.
Okay. So now,
I mean, the graph you made one mistake. I wanted to point out that.
in the graph,
Yes.
the question number 1.
Yes, ma'am.
So tomorrow, you have session. Do you have any other subject session from 8 to 10?
Statistics.
No, ma'am. Yeah, in
Someone says statistics. Stats.
Yeah, ma'am. That is 6 to 8 p.m. I think.
Ma'am, are you
No.
talking
So
about
it is there on 8 to 10.
morning 8 to 10 or
8
yeah.
to 10.
No,
It's 8 to
evening.
And we
10.
have it at 8 to 10, the statistics one.
Can you explain me?
Okay, you have stats one.
Sorry.
ma'am, we have
Yes.
a statistics, ma'am, 8 to 10, ma'am.
Yeah,
And si-
ma'am. 8 to 10
And
is
6 to
statistics.
8, it
And
is
six and 6 to 8 SCT,
Wait,
ma'am.
wait,
computer
wait.
session. Yes, city.
I'll just say the slots. You guys will answer which will. Okay. So morning 7 to 9.
It's free,
Yes,
ma'am.
ma'am. Yes, ma'am.
Free,
Possible?
ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Possible.
Yes, ma'am.
Yes,
Yes, ma'am.
ma'am.
If possible, 4 to 6. What about 4 to 6?
And then
Morning
we'll
4 to
have
6.
classes in
Ma'am.
continuity, ma'am.
Yeah.
Sorry, what?
We'll have classes in continuity 4 to 6, then 6 to 8, and then 8 to 10.
Ma'am,
Yeah,
7 to 9
3
would be
to
okay.
ma'am, 3 to 5 is okay, ma'am.
Ma'am,
7
but
a.m. is the
in
best
the
time,
morning,
ma'am.
all of us cannot take the morning session, ma'am.
Yes, ma'am.
Yeah, morning I
Ma'am,
also
3 to
am
5 is
little
okay.
busy. So.
3 to 5 is
Yeah,
okay.
ma'am,
Ma'am,
4
can you
to
Ma'am,
6.
please
3 to 5 is okay, ma'am. After that,
around
Yes, ma'am. 3 to
Yes,
5.
ma'am. 3 to
we have a
Just
one.
say one by one. Shh. I'll ask someone and call the name and then you'll answer. Yeah, Vishwajit.
Yeah, ma'am. 3 to 5 is okay, ma'am. We have a gap after that 1 hour, and then 6. We have a class from 6 onwards.
Okay, 3 to 5. Is that fine for everyone? 3 to 5?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yeah, okay,
Yes,
no
ma'am.
worries.
Yes, ma'am. It's
Morning or
okay, ma'am.
afternoon.
Yes, ma'am.
Just wait. Someone says something. Yes, Afreen.
Yeah, I'm saying morning or afternoon, whichever suits you. I just didn't want the classes to be in continuity, that's it. So 3 to 5 is
Okay.
fine. Even 7 a.m. is fine.
You already have one session scheduled for mock. What was the time for that particular session? I mean,
It
No
was
any
it was
session
10
scheduled
to
with mock
ma'am, it
8
was
to
10 to
10.
no 10 to 12. It was
okay.
Friday. It was, ma'am. It was showing, ma'am. Day before yesterday, I saw the calendar, and it was showing, ma'am, 10 to 12 a mock session for maths.
10
But,
to 12 for mock. Okay.
yeah, but now it
Fine.
is not showing.
So I also don't think I can discuss the mock question because yeah, those are a little tough question. It required little, and I am also not prepared for calculus question. So it will take more time if I just sit and solve, right? So what we can do? 7th question also will take time.
Ma'am, this difficulty level in exam 2.
You can assume that's why it's not. Assume that at least.
Ma'am, this is so difficult.
Ma'am, can you take mock graph theory questions? Last question, ma'am.
Sorry, what?
This mock graph theory last question, can you take
You
now?
can draw the graph in Desmo.
See.
Ma'am, that
Yeah,
Riemann
advantage-
sum is too much difficult over there. Can we able to solve that question, please?
Yeah, that last question. 2 cases they have given like.
This graph theory question or Riemann's? This this
Graph theory
question. No? It's not that too difficult. Just understand the language. What is actually asking them. So
Yes,
see,
ma'am.
I'll explain one thing. So first thing it says that nodes represent the location of employees, right? And the second thing it says that edges represent the road connecting these locations. Now they explain that how can we send a cab. So each cab can be pick up employee from only one location, and the all the cabs needs to be. I mean, we want to find the minimum number of cabs, and there is one restriction that an employee is walking. An employee is willing to walk at most one road length from their current location. So that means, suppose you will send. Let me share this. I'll just give you one hint. So suppose an employee, suppose I'll send a cap to this vertex. Then what happened? Any employee which will be situated over this location or this location, he or she can walk up to this particular vertex. So that means if two vertices, if these vertices are adjacent to this vertex, so that means it's enough to send a cap at this particular vertex. Then we don't need to send a cap over these two vertices. So that's why that's how you have to make your decision. So this is a one vertex, right? There we can send a cap, and we can choose another vertex.
So minimum vertex
similar way.
covering can we use, ma'am?
Yeah.
But I got 4 answer, but answer.
No, not minimum vertex covering. Here you have to use coloring problem. I mean, what you have to do? No, not coloring also. Because coloring
Minimum vertex cover.
independent set you have to do. Correct. You have to find out largest independent. Largest independent.
Ma'am, for case
In
1,
that case, we
minimum
need to
vertex
find that.
cover.
Yeah, minimum vertex cover. Then minus it, and then we get the answer.
Yes.
Maximum independent set.
Maximum independent set we have to find.
Yeah.
Because if you take this vertex, then these two locations we don't have to send a cap. If I take this vertex, then again this location, this location, this location, I don't need to send a cap. Again, if I take this vertex, again also this location also. So that means I have to send the cap at 3 locations only, first, second, and so since these are the independent vertices, moreover, I think these are the largest independent set in this graph, because I
And for
cannot
case one, we are finding minimum
I'm
vertex
talking
cover,
about
right?
case
Okay.
minimum vertex cover, you can say.
Yes, ma'am, it is
This
minimum
is not
vertex
a
cover.
minimum vertex cover, no? See, whatever I'm saying, that if I number it, so these 3 vertices. This is not a minimum vertex cover, I think so. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the 10 vertices. And I'm saying that I just want to send the cap at the location number 1, location number 8, and the location number 6. So if I send my cap to these 3 locations, then any employee can be picked up, right? We can pick any employee. Is that fine? The statement is correct?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
No, because if I send a cap to vertex number 1, then these employees, whatever are there, I mean, whatever employees there at location number 10 and 2 can walk up to location number 1 and take the cap. So that means this would be an answer. Now, since you guys are saying that this is a minimum vertex cover, but this is a vertex cover, I can say, because no, I cannot say this is a vertex cover.
Ma'am, you can also check the options.
It is
too.
an independent set, ma'am, not a vertex cover.
Not a vertex cover. It is an
I
largest
actually gave it as
independent
the
set, but
largest
it's not
independent
a-
set, but instead it turns out it is a like vertex cover.
No, it's not a vertex cover.
Vertex cover, ma'am.
Ma'am, check the options actually. Check the options.
Independent said they said that is a wrong option, ma'am. That I too have that the same.
Finding the maximum number of element in independent. So I could solve it. So maximum number of element. I think it is a maximum. See, this is one kind of answer, right? This is one answer I find. I find that the number of location should be 3. Now let's check that is it a maximum, is it a largest independent set or not? Okay. So
Ma'am,
that
the
means
largest
I'm
would be
considering-
1, 9, 4, and 6.
So that's the kind of
1, 9, 4, and 6.
Okay. Can we extend this particular set?
Yes,
itself?
ma'am. Add
1,
3 to it.
6,
No, we
and,
cannot add anything.
10
Ma'am,
we
can't
can add,
add.
no?
No,
10,
ma'am.
10, 10.
Ma'am, 10 is
1
connected to
and
1,
10.
ma'am.
2 is also connected, 5 also connected, 7 also, 9 also, 3 also, 4 also. So that means this set cannot be extended,
Yeah,
but we can consider any other independent set. So let's try to
ma'am.
consider what is the largest independent set.
1, 9, 4, and 6. 9,
9,
4, and 6.
4, and
6.
6, correct. 1, 9, 4, and 6. So this is the largest independent set. So I'm sorry, this is not a largest set. So that means this problem is just intuition problem. Here you don't have to consider the vertex cover nor the independent set, nothing. So the basic answer is 3 only.
Ma'am, actually, there is a similar kind of question in the activity. That's why I said this is a minimum vertex cover, because there was a question like this. Exactly, not like exactly, but the pattern was similar. That's why I said it is the
That
minimum
camera problem, the room has to be viewed via some
and
camera.
yeah, there is an employee to building problem also, which is also similar to this.
It
Maybe
has to
that
be
one would
something,
be
ma'am.
similar. But see,
Either it is
here,
vertex cover or maximum independent set. Yeah.
no, that's not the case. It is neither of them. The largest independent set is this.
Which
If you
problem you are
consider the
trying to solve?
vertex cover,
The mock,
Is it
sir,
case
mock.
1?
17.
Yeah, case 1,
17.
sir.
Sir, case 1.
Case 1. It's simply a coloring problem.
Coloring, I also thought that it's a coloring problem
It is a
because
coloring
of
problem. If you
3
color
colors
it,
we can use.
you can color it in 3.
Minimum color should be
That will be the number of
required.
caps required.
Case 2, we tried coloring.
I mean,
Yes, correct.
it's both coloring and
Case 2 can't be
Case 2 is the coloring. Sorry, case 2 is the
Huh.
coloring.
Yes, sir. Case 2, we tried
Case
So what
coloring.
two
is case one? So what is case one?
No,
That will be maximum independent set.
no,
Oh,
it's not
okay,
a
okay,
maximum independent set. No.
Yes, it
No,
is.
sir. Sir, answer is not correct, sir, of maximum independent set.
Yes, it is not
Maximum
correct.
and maximal
Oh, sorry.
two are different.
Maximum will come.
Maximal is not. I mean, it's not either based on vertex cover nor on largest independence. It could be a first thing is could be a coloring, but let me think about it. If we
Case
color
2
this
is coloring.
graph, case 2 is coloring, so
Yes, that is
this
confirmed.
won't be a coloring.
Oh.
But yeah, this is neither the largest nor the vertex.
I mean, sir,
got the
ma'am, I
answer
think it's just a logical question they are
It's a
trying to
logical
put.
question. Yes.
Yeah, correct.
Simply, you just have to consider whatever the notes you will do. I mean, you will send up caps, right?
Ma'am, by definition, vertex cover says any vertex that cover all the edges, and case 1 requires to cover all the edges.
It's not containing all the edges. I pick 1, 8, and 6. So 1 is covering these 2 edges, but this this particular edge is not covered by 1, 8, or 6. Right?
In case
It's
1, we
not
are
a
not
vertex.
worried about the edges. We are only worried about the connectivity of the vertexes with the minimum cluster of.
Yeah, but if you are saying that it is a problem related to vertex cover, then we have to consider.
It's not a vertex cover. Vertex cover.
It is not a vertex cover, right?
Correct.
So it's not a vertex cover.
I think people misunderstand. Vertex cover does not mean that we are interested in covering the vertex. We are covering the edges from the minimum vertex. That is where we put the camera. Yeah, we covering.
No,
all
see,
the edges.
minimum is also not included in definition. I mean, if you explicitly say that I want a minimum vertex cover, then minimum is required. Although in general vertex cover, you can take any number of vertices. It's not required.
What was the aim? What is the aim of a vertex cover? It is to cover
It's
all
actually
the edges.
covering all the edges.
Here we are
that's
not
why-
interested in the edges, right? We are interested in collecting the
Nodes.
pixel from the vertex. That is why it is not a vertex problem.
More about reachability over here.
Connectivity with the minimum number of vertex.
Yeah, about reachability.
Reachability. If they are connected, you pick up those set so that all the vertices are connected to that.
Okay, sir.
One question to both Bhaskaran sir and ma'am. When we are talking about this vertex cover, what are we most concerned about, the edges or the vertex?
It is to cover all the edges from the minimum number of vertex.
So that is
You recollect the examples
minimum.
given. The camera to be kept, the number of cameras should be less. It should cover all the roads.
Yeah, that particular problem is based on vertex cover.
That is called
Because
vertex cover.
there you have to choose the camera. I mean, yeah.
We are interested in
You want to
covering the edges from the least number of vertexes. That is the way where you got to apply the vertex cover.
Okay.
I got the same answer by using minimum vertex cover. That's why I was talking about it.
Vertex cover, the minimum vertex cover will be, minimum vertex cover will be how many? How many vertexes you got?
Yeah.
I got 3 actually.
No. Okay.
I mean, if we go with your definition, Bhaskaran sir, then minimum your answer is wrong. Edges are not getting covered.
Which answer is it?
Here, her answer, sir. Her 3 vertex. All edges are not getting covered with all 3
Yes,
vertices.
they are connected.
That's 3 is not possible, sir.
Correct. I mean, this question is not
But
neither.
3 is the right answer. I have solved it and I got the right.
So
Sir, but
Three is
you're
the
talking
right
about
answer,
minimal
but
vertex cover.
approach of vertex, minimal vertex.
Problem
cover
is it vertex cover or maximum independence?
No, they are
It
both.
is
are
neither
not,
of them.
it's neither of that.
Neither of them. That's what.
It's a simple logic. You look at the vertexes which are connected to the many number of vertexes, most connected vertexes. You pick up, you will cover all the vertexes. It's done.
Correct.
It is not to do with any of this other methods that
So, sir, we can't actually say what it is actually. So neither of them, right?
it is neither of them.
Okay, sir.
At least for the first case 1. Case 2, yes, you can use the coloring problem.
You to employ a sign for different centers. Come should. Ma'am. Yes.
Ma'am, for the exam, like activity questions, practice assignments, and PYQs are enough, ma'am.
Sorry, repeat it again. I'm not able to.
Ma'am, she's asking whether the PYQs are enough or she has to go through all the activities and practice questions as well.
See, I won't say the PYQs is enough, but since you have very less time, so I suggest go through the practice and grade it as well. If now you want to cover whole thing, I don't think it's possible to cover all those PYQs, all those activities. So your main focus, I mean, just prioritize your work. First, you will do practice assignment. First you will do mock. Secondly, you will do all practice assignment, then graded assignment, and then previous term questions. Okay. And then at the end, you will do activity questions. So that should be your step.
When we explain the minimum cost planning to you, but not I have got 40 as the answer, but they have given us 39. Could you please discuss that question?
You're asking about minimum cost penalty, right?
Is there in mark 15th number?
That is the question.
Yeah,
you
that
saw
particular
before, no,
discussion.
ma'am.
We already discussed this question, minimum cost penalty question from the mock. No, yeah, this particular question I just discussed in this particular.
So the answer is.
You can go check the.
Ma'am, can you please clear the timing for tomorrow's session?
I can't tell you right now because you guys are not. I mean, I have to ask sir for that, right? But I'll definitely schedule one session for morning. That much I'll ensure you.
Ma'am, timing will be available on the calendar by tomorrow morning.
Yeah, morning slot is available, and also I have to confirm with sir that which.
But it will be updated on the calendar itself, no?
It will be updated on your calendar. Either
so we have to check continuously for the sessions on the calendar.
See, once you will check, since I won't take the session on morning, obviously.
Okay.
So you can check
when you are free
12.
and you are going to take this particular class only.
Well, let's see. I'll try to take.
Okay, and timing. It will be in second half for sure. It will be in any time during the second half before 6.
Before 3.
6 because from 6
after 3 you can assume. After 3 at any slot. See, wait a minute. I'm just telling you that if possible, I'll take class from 10 to 12. Or,
in the morning.
Between your no, 10 to 12 in the evening at night. Or I will take the class from 4 to 6. I know you guys are already having continuous classes, but just manage for a day.
Okay.
That's all I
Ma'am, if possible, can you take any class in the morning time, like from 10 to 12 or so?
Yeah, see, I have to check with so many people, right? This is an online meeting, so I have to check with sir first. He will schedule whatever time is free. Okay. So I'll let you know by 12 itself. Okay. So
In the
before
morning
12, you
too.
will
Okay,
get
okay.
before
Okay,
12
done. Okay.
p.m. you will get
It's
the
fine,
notification.
ma'am. Okay.
Ma'am, ma'am, can you hear me?
Yes. Yeah.
I mean, if you're comfortable with like 10 to 12 p.m., ma'am, then we can continue the session right now also.
I
No,
think
ma'am.
not
right now, ma'am.
everyone
No,
will
ma'am.
get exhausted.
Ma'am,
I
no.
also get exhausted. I can't.
They will
Tomorrow you
get the
can
record.
discuss this session, ma'am. Not now, ma'am.
Tomorrow 10 to 12 or maybe we'll finalize whatever.
Yes, ma'am.
tomorrow.
Ma'am, if possible,
Mock
please.
discussion particularly. Yeah,
Yeah,
Vibhav?
ma'am.
Yes,
Particularly
ma'am, we
mock
need it,
discussion.
ma'am, because it is too difficult for us to solve.
But ma'am, yeah,
okay.
if possible, please don't go for that 10 to 12 schedule. Like if possible for you.
Ma'am, even if tomorrow you are finding it difficult to take the class for whole of the day, suppose let's consider this situation, then the day after tomorrow also you can plan in the first half.
The first half I can.
No, sir.
Day after
I'd
tomorrow I
say
have one class.
tomorrow is better.
When will be your end term exam? End term exam
On
is
Sunday, ma'am.
First of September.
1st of September.
So there are 2 days you can schedule either or tomorrow, but don't schedule on Saturday second half, because it won't be of any benefit to us. We won't be able to revise it.
Yes, right.
Okay, fine. I'll try to
I
schedule.
have clarifications.
Yeah, Navish.
Ma'am, take the session in tomorrow second half.
See, it's not in my hand. If I want to take, then I can take at any time. Na. Here I have to cooperate with 2 to 3 persons. So if they all agree,
All right.
then
I think you coordinate with them and then communicate to us. That is
then I'll communicate at the time.
I think that's
okay.
we should be
But
prepared to
definitely
sit for
I'll
a
try
long.
to take it tomorrow.
Even if it is late, it doesn't matter. Let us plan and sit for a longer hours.
Yeah. Okay, so
Ma'am, can I continue?
yes, Navish.
By any chance, can you share the PDF like in which we like today of today's revision? Like, can you share in the chat?
Yeah, I'll share in the chat.
And one more thing, ma'am. Like as for the previous question which we were discussing, we had like lots of opinions about which concept like we're supposed to apply for that question. So like if we were to do this in exam, like how will we be able to identify which concept to apply for which question? Because from graph theory, like most of the questions will be asked. So any
So yeah, so we won't give us that much choices. I mean, here two option for first option contain about independent set, second contain about vertex cover. So there we just put a one option, that is it related to independent. I mean, we just want you to verify it via one concept only. I mean, we won't give such a large number of options that could be true. Independent set, vertex cover, or something, right? Here we have to check both of the things, independent set and vertex cover. And obviously it's tough to check two concepts in that short time, right? That's your concern, right?
Yes, ma'am. Thank you.
So in exam, either they will get, I mean, they will shorten this question. They won't ask such.
Okay.
I hope they won't ask.
I mean, the next mock session, will you take this remand question of this mock?
Yeah, I'll take all the mock question because as you guys told that
So little bit confusing even for me also, ma'am. I solved many problems, but
okay. Yeah.
okay, thank you, ma'am.
Either I will take or someone else will take, but I'll.
Thank you.
Okay, thank you, ma'am.
Yeah, thank you. Guys.
Thank you, ma'am.
Yeah, someone wants the PDF now, so I'll
Thank
just
you, ma'am.
Thank you, Bhaskar sir.
Yeah, ma'am.
Thank you, ma'am.
Bye, good night.
Thank you, ma'am.
Bye, ma'am.
Yeah.
Thank you so much, ma'am.
Thank you, ma'am. Good night, ma'am.
Good night. Bye.
Bye, guys.
Bye. Sujit.
And the PDF she shared is that visible?
Nope. Share anything. Yeah, it is over here.
No, like
Yeah.
it's like
It is
blank
available.
for me.
It will get the stay for few minutes. It will be visible. The annotations will be visible.
Okay.
Hello, Shara, are you there? Hello.